In section 10.4, we study the form of the ellipse. So we'll be working on graphing and writing the equations of ellipses. Ellipses are very much like circles, only an ellipse is a circle that has been stretched and flattened a little bit. If you remember with the circle, we moved the same distance out from the center, and we were able to create a circle. If you took and you stretched the circle, in this case vertically a little bit, you'd see that the distance this direction is greater than the distance this direction. And that's what happens with an ellipse. They're very similar to circles, and what you need to find is you need to find this distance and this distance, plus another distance, because the circle has a center, which the ellipse does as well, but the ellipse also has a couple of focal points that help define its shape. So, like the parabolas, ellipses can be horizontal, meaning they're longer this direction than they are this direction. Or they can be vertical, which means they're longer this direction than that direction. Okay, so it's not really worth spending too much time worrying about the form of the ellipse in terms of memorizing horizontal and vertical. If you follow the steps to go through identifying the distances, it'll all sort of work out for you, and they'll end up being the correct shape. So it isn't that you've got to struggle to memorize these forms. It all sort of works out this way. Okay, so standard form for an ellipse: x squared over a squared plus y squared over b squared equals 1. The key here is it has the plus sign just like the circle does. If it was a minus sign, then it would be a different form. What we need to find out are covertices and vertices. The vertices are the far points the long way through, so these would be the vertices, and the covertices are the furthest points the short way through the ellipse. So those would be the covertices of here and here, vertices here and here. And we can find those by finding the square roots of these denominators. So the key thing here is that when you start looking at, oh, this one has a squared in the first fraction, and this one has b squared in the second fraction, and here they're reversed, the thing you need to remember is that a is greater than b. So which one's bigger? That's what you really need to worry about. Which is the larger number, the a or b? The larger one, the square root of the larger number will be your vertex, and the square root of the smaller number will be your covertex. And another reason why I'm telling you, no, don't spend too much time worrying about memorizing the difference between these forms is that the square root of this number I'm going to graph on the x-axis, and the square root of this number I'm going to graph on the y-axis. Or another way to put this is, I'm going to move this distance left and right of my center, and I'm going to move this distance up and down from my center. And if I don't worry then about which one is A and which one is B, I'll still end up graphing the ellipse correctly. Okay, so in this case, if you look at the square root of 121, I'm going to move 11 spaces from center. Center again in this form is at 0, 0. Later we'll look when center is not at 0, 0. And for my covertices, I'm going to move 10. Okay, the key thing to remember is this sort of implies, the book gives you this information, and it almost implies that the vertices are a location that you can find based on finding the square roots of these numbers. But in reality, this is a distance that you travel from the center in the x direction, which would be left and right. And this is a distance that you travel from the center up and down. Okay, so it's a distance, not a location. That's important. Okay, so if I look at this particular problem, then my vertices, you can see, are going to come off the square root of 6, so that's going to be 0 plus or minus, square root of 36, which is 6. So 0 plus or minus 6, and then my covertices, this is a smaller number, would be plus and minus root 12, 0, and if I simplify that, that's going to be 2. 2 root 3 plus and minus 2 root 3. If you're thinking about graphing this, the square root of 12, 9 is 3 squared and 16 is 4 squared, and 12 is pretty close to halfway between them. So I would tend to think of that as being about 3.5 as you're graphing it on the graph. So if I go through and I'm actually going to graph this ellipse, again, centered at 0, 0, I'm going to take the square root of 121 and I'm going to graph it on the x-axis, so that's going to be plus or minus 11 right and left, so that would be 11 right and 11 left, that's 2 points. I'm going to do plus and minus 10 on the y distance, so that's going to be up 10 and down 10, and this is my ellipse. Now, the ellipse also has 2 foci, okay, so a couple of foci, and those can be found by using something similar to the Pythagorean theorem, but it's minus. So C being the distance I move from center to locate the focus is going to be equal to a squared minus b squared. So c squared will be equal to 121 minus 100, so it will be equal to 21. And if I take the root of that, c will be equal to plus and minus root 21. Now what's important is when you find this value, you're going to move this distance from center in the same direction as your larger denominator with the vertex. So in this case, this is between 4 and 5. So it's 1, 2, 3, 4. Let's say it's about 4.5 in that direction. 1, 2, 3, 4.5 in this direction. So you can see that if I'm worried about identifying my vertices, they were at plus and minus 11, 0. My co-vertices were at 0, plus or minus 10. And my foci were at plus and minus root 21, 0. And this is the whole ellipse, a little shaky line, but this is the whole ellipse. Okay, taking a look at the other problem that we had. Now you see the vertices in this case are going to be graphed on the y-axis. So I'm going to have plus and minus 6 on the y-axis. So I'm going to go up 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. On the x-axis, I'm going to go plus or minus root 12, right, which is again between 3 and 4. So I'm going to go 1, 2, 3, 1, 2, 3, and here's my ellipse. I still need to find my foci, so c squared will be equal to 36, in this case the larger denominator, minus the smaller denominator. So c squared will be equal to 24, so c will be equal to plus or minus root 24, which is just about 5. And I graph this on the same axis that I graphed the vertices. In fact, you can see that if I graphed it on the other axis, I'd go outside the ellipse, and that's not possible. This must be inside the ellipse. 1, 2, 3, 4, 5. So it's just a shade under 5. And those are my foci. Okay, so 0 plus or minus root 24 were my foci. 0 plus or minus 6 were my vertices. And plus or minus root 12, 0 were my covertices. Now a lot of times people want to know, well, what's the point of the focus? If you go from any point on the graph, let's say we take this point, the distance from here, from one focus to the point and then to the other focus, the distance of this plus this will be equal to the distance on any other point. So every point on the ellipse will have the same value if you find the distance between the two foci and that point and add them together. So if I wanted to draft an ellipse, let's say I needed to cut a perfect ellipse out of a piece of plywood or something, I could put in my foci and then use a piece of string that was a specific length by putting a pencil here. And if I drag that pencil to the furthest limit of the string, I'll be able to draft an ellipse. That's very helpful if you ever want to draw an ellipse that's not out of shape. If I want to write the equations of ellipses, what I need to do is I need to simply take these values and put them with the axis that they are related to. So I know I'm going to have x squared, I'm going to have plus, I'm going to have y squared, and these things always equal 1. Okay, now 6 was a y coordinate, so I'm going to square 6 and put it under y, so that's 36. And negative 2 is an x coordinate, so I'm going to square that and put it under x, and that's how you write the equation of an ellipse. Same deal over here. I know I'm going to have the x squared, I'm going to have the plus, I'm going to have the y squared. Those never change. 9 is an x coordinate, so 9 squared goes here under x. And 8 is a y coordinate, so negative 8 squared, which is 64, goes here under y. And that's why I'm saying if you follow these basic rules, the square root of this gets graphed in the y direction. It's a distance moved up or down. It will the graph will work out to be oriented horizontally or vertically without you having to figure out which it is before you start. When we are not centered at 0, 0, then we have this form. Excuse me. When we're not centered at 0, 0, then we have this form, x minus h squared plus y minus k squared equals 1. And then a squared and b squared change based on whether it's horizontal or vertical. In this case, you see that 49 is bigger, so that's the a squared. The a's and b's move around. Okay, so this is the form I'm working with, but what I'm going to do first is find the center. So the center is at hk, like all the other forms we've been working on. So that's going to be at 3, h is 3, and k is negative 6. So if I go to 3, negative 1, 2, 3, 4, 5, 6, there's my center. Right? And if I want to graph my ellipse, I know that a squared is equal to 49. I know that b squared is equal to 25. So that means that a is 7. I'm going to move 7 in the y direction. That means up and down. 1, 2, 3, 4, 5, 6, 7, and there's a vertex. 1, 2, 3, 4, 5, 6, 7, and there's a vertex. Okay, so my vertices were at 3, 1, and at 3, let's see, 7 down from my center, negative 13. Right, my center is at 3, negative 6. I take the square root of b squared, that's going to be 5. That's going to be in the x direction, right or left. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now here's my ellipse. I'm pretty bad at drawing ellipses. So you can see here, negative 6. We went from 3 to 5, that's 8. And we went 3 minus 5, that's negative 2, negative 6. Those are my co-vertices, and I still need to find my foci. Now my foci are going to be a distance up and a distance down, and it's going to be c squared is equal to 49 minus 25. So c squared will be equal to 24. So c will be equal to root 24. So that's almost 5. 1, 2, 3, 4, and just barely less than 5. 1, 2, 3, 4, and barely less than 5. What's a little complicated when you try to put these foci together is that the x-coordinates are going to be the same. They're going to be at 3. And then it's going to be the y-coordinate, right, which is -6, plus and minus root 24, because I went up root 24 from there and I went down root 24 from there. That's how I would identify my foci. Okay, so that's graphing an ellipse that is not centered at 0, 0. If I want to write my equation now, this is a little more complicated. They're giving me vertices and they're giving me foci. Okay, so let's make a really quick sketch just to make sure that we are clear about what we're talking about here. So you notice that everything has an x-coordinate of 2. Right? So I have vertices at 2, -3, 1, 2, 3. That's 2, -3. And at 2, 6. 1, 2, 3, 4, 5, 6. Now, halfway between these 2 points is going to be the center. Right? I also have foci at 2, 0. 2, 0, that's a focus. And 2, 3, 1, 2, 3. And the center is going to be halfway between those. So it's going to be at 2, 3 halves. That's my center. That's helpful because that means that h is equal to 2 and k is equal to 3 divided by 2. And now, how am I going to find my covertices? I can write a lot of things down right now. I know that the distance from center, right, that's the distance from center to the vertex. I know that that is the difference between 3 halves, right, 3 halves and 6. So 12 halves minus 3 halves is 9 halves. That's going to be equal to A. Okay, the distance from center to the vertex. The distance from the center to a focus is 3 halves. B is equal to 3 halves. I know because I go from 3 halves down to 0. That's a distance of 3 halves. So I've got 9 halves is equal to A. 3 halves is equal to B. Now, I'm sorry, is equal to C. That's my mistake. That's not B. That's how I found the focus. So remember now, we're going to use this guy. C squared is equal to A squared minus B squared. So I know 3 halves squared is going to be equal to 9 halves squared minus B squared. When I square this, I'll get 9 fourths. When I square this, I'll get 81 fourths. If I add B squared and subtract 9 fourths, B squared is equal to 81 fourths minus 9 fourths. That's 72 fourths. The good news is when I put this value into my equation, I need B squared. So I'm going to have x minus h squared. This is vertically oriented, so that's going to be over B squared, plus y minus k squared over a squared is equal to 1. And now I just need to start plugging my values in. H is equal to 2, so I'm going to have x minus 2 squared over B squared, which is 72 fourths, plus y minus k, which is 3 halves, squared over a squared. Well, a is 9 halves, and if I square it, I'll get 81 fourths. equals 1. And you could leave it in this form, or you could actually invert these and multiply, in which case the 4's would go into the numerator, and it would look like this. 4 times x minus 2 squared over 72 plus 4 times y minus 3 halves squared over 81 equals 1. Okay, I would accept either one of these from you. That would be fine. I think the one on the left, this one is probably simpler, but I will happily accept either one. Okay, so that was graphing ellipses, and next we'll be moving on to graphing hyperbola.